So our next step is to find a formula that describes our setup here in this picture. And the one thing we want to remember is that this is our positive value representation. So we know that when we have positive values for the focus, the object distance, and the image distance, it's on this side of the spherical mirror. And if it's negative, it would be over on the other side of the spherical mirror. So this is positive, this is on the left-hand side, negative on the right-hand side. So let's take a look at similar triangles. If I start at O prime, work my way to A, come back along the axis, the center line, and back up and from A to O and then O to O prime, it turns out that that is a similar triangle with I prime A I. So I have that HO over HI is equal to DO over DI. Now for a second set of triangles, this time we're going to go from O prime to F to O back to O prime. So we have that triangle. Didn't stay in the lines very well. Okay, and now since this line from B to I prime is parallel, then I have the same distance from the focal point down to this line from B to I prime, and then I'm going to have a similar triangle from the focus to B back to this new image distance and back up to F. So in this case, my object height over my image height is going to be equal to, well, for this first triangle that I have my object height, then the distance from O to F is just DO minus F. And the distance from the new image location from the focal point to B is just F. Now I can set these two equations equal to each other. And I can do the cross product. And move things around. And rearrange. The F is just going to factor out, and I can take and divide both sides by DO plus DI. But this form here, we've seen this form before, and we know that with this form, that's equal to 1 over DO plus 1 over DI. And if I take the reciprocal for the first part, this reaching part, I get 1 over DO plus 1 over DI is equal to 1 over F. And our magnification, M, turns out to be, in this case, you see that the object is oriented in the up direction, the image is oriented in the down direction, so our magnification, HI over HO, ends up being a negative DI over DO. Now remember, this is our positive value representation. We can use this equation without any changes with virtual images that occur behind the spherical mirror. So in this case, our focus is positive because it exists on the left-hand side. Our distance to the object, DO, is positive, but our image distance is negative because it's on the back side. Here for a convex mirror, notice that C is negative, the focal point is negative, the distance to the image is negative, but the object distance is positive because it's on the left-hand side of the mirror. So keeping track of these negatives and positives will allow us to use these two equations without any modifications for convex or concave. Just as long as we keep our signs straight, we realize which directions are positive and which directions are negative, we can solve any problem just using these two equations when it comes to a spherical mirrors, either convex or concave.